This is where it gets good. We're looking at subsets today. And the idea of subsets are one set within another one. And we care about these because we care about what's equal, which one is equal to another one. Would you highlight every element of B is an element of A, then B is a subset of A. And all B is in A. So what I like to do, if B is a subset of A, this is the way we write subset. There's a few things that we can say that's kind of weird. We can say that A is a subset of this. What's that? What's that U? A is a subset of U. Do you know what the U is? The universe of all elements. So is A a subset of everything? True. Is the empty set a subset of A? Yep, that can happen. Is A subset of A? Yeah, all of these are what they call the trivial subsets, but what's neat about these is these are all true. And you can use those. But if B of A is such that B is not equal to A, and B isn't the empty set, then B is what they call a proper subset. This is what you're thinking of and I'm thinking of, is this little bubble within a bigger bubble. Okay, there's more in A. They're not the same things. When I look at this, it could be B is equal to A, right? So how do you think we write a proper subset? Where they're not equal. B is B is not equal to A. B isn't the empty set, but B is a subset. We just leave out the little equal sign. This is the proper subset. So these are different. This opens it up to them being possibly equal. Well, let's take a look at some subsets. And let's look at some subsets of, we're going to start here with the empty set. So I'm going to start with this one. How many subsets are there of the empty set? There is one. What is it? The empty set. That's one. Yep. How about if I have, we're going to put A in here, little a. How many subsets are there of A? Kind of talked about it. A is one. What else could you have? The empty set. Yep. Okay. Let's keep going. S of 2. Now we're going to have A comma B. And what are the subsets of A comma B? A, B, what else? A, B, and what else? The empty set. Yep. You see anything interesting forming here for pattern? Let's try 3. A, B, and C. So what are the subsets of this one? A and B. So you could have A, B alone, C alone. What else? You could have A, B. You could have, we'll go B, C. What else? A, C, and A, B, C, and there you go. Now, let's look at the numbers here. The number of S0 in S0 is how much? 1. What is it for S1? 2. What is it for S2? 4. N of S3 was how many? What do you expect it to be? 8? Is it 8? It is 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8. So if I gave you M terms, what is the number of subsets for M terms? Just 2 to the what? Here m is 0.
Oh, okay.
Here m is 1. Yeah, it's just to the m, isn't it? Isn't that cool?
Or I guess, yeah.
M is what I was thinking, how many there are, and then different elements there are, not repeaters. And then the number of those, the cardinal number of those, is 2 to the m. Yep. So that's what they talked about here. The power, when they say the power of the set, okay, the power of the set is the number of subsets, m elements, 2 to the m. And PA, the power of the set PA of A, so 2 to the m gives you the number of sets that we have. And we proved that with 3 already. Okay, so here's a couple of things you're going to use in future proofs. 2 sets, A and B, are equal. They're equal if A is a subset of B and B is a subset of A. That makes sense. A is a subset of B and B is a subset of A. We proved 2 sets A and B are equal. And this, would you highlight this one right here? This is used the most in the proofs that we're going to be doing. Is if we're showing they're equal, X is an element of A, then X is an element of B. What does this little arrow, double arrow mean? Yeah, so you've got to do this 2 ways. You do it this way, if X is an element of A, then X is an element of B. Or if X is an element of B, then X is an element of A. A little tricky, but not too bad. And here you can see the arrows going those 2 different ways. Here is the proof for that. If A and B are equal, then A is a subset of B and B is a subset of A. It follows that A is equal to B. So what they did first is they said X is an element of A. If X is an element of A, then X is an element of B, because A and B are equal, right? X is an element of A, then X is an element of B, because A and B are equal. This establishes that A is a subset of B. Then if Y is an element of B and Y is an element of B, then Y is an element of A, then B is a subset of A. So since we showed both ways, A is a subset of B and B is a subset of A, it follows that A is equal to B. So they used that definition here to prove that if 2 sets are equal, those are true. All right, go to the homework, please, and give a try 2 A, B, C, D, and 3 A and B. For 3A, it says prove that A is equal to B. And so I showed you if X is an element of A, X is equal to A plus 1/2, where A is an element of Z. All I did is I took this part, I just started out with that. Then I want A plus 1/2 to look like B minus 1/2. So what I did is I added 1 so I could have A plus 1 minus 1/2. Is that still 1/2? Yep, so A plus 1 minus 1/2 looks a lot like B minus 1/2. So what does B have to be equal to when we compare these? A plus 1. Now, if A is an integer, will A plus 1 be an integer? So if A is an integer, then A plus 1 is an integer. Therefore, X is definitely an element of B. Okay, we're going to try the next one. And I'm going to give myself a little more space. We're going to start off with X is equal to B minus 1/2, where B is an element of the integers. What should my next line be? I want it to look like a plus 1/2 is what I want it to look like. So if this is plus 1/2 and this is b, what do I need to do here to, yes, minus 1. Now it's still b minus 1/2, but it looks like a plus 1/2. Does that make sense? And so then we'll say, let's see, b, yeah. So therefore, x is equal to a plus 1/2, where a is equal to b minus 1, which is an element of z. So if b is an integer, will b minus 1 be an integer? Yep. If b is an integer, then b minus 1 is also an integer. So therefore, x is an element of a. A little tricky, but kind of makes sense. And then we're going to say, finally, since, thus, therefore, whatever you want to write, thus, a is a subset of b, and b is a subset of a, then a is equal to b. Okay, and I'll let you try this b here. It says a is equal to x such that x is equal to the square root of y, and y is an element of the positive real numbers. B is also equal to the positive real numbers. So if x is an element of a, x equals square root of y, where y is greater than 0, what does that tell you about x? Yeah, if y is greater than 0 and you have x equal to this, if y is greater than 0, x also has to be greater than 0. Don't put, and then they said if y is greater than 0 and square root of y is greater than 0, then x is greater than 0. Just some kind of seemingly straightforward. If x is greater than 0, is x an element of the positive real numbers then? Yep, so we got it. Now you're going to do the other one. If x is an element of b. Give that a try. And then there's a 4, and the 5 is the challenger.